Sometimes it's easier to see on a graph. If I apply a certain force, there's going to be a certain force of friction. So I apply 1 Newton, and force of friction would be equal to 1 Newton. I apply 2 Newtons, 3 Newtons, 4 Newtons, 5 Newtons, let's say up to a certain amount. Well, there's going to be this maximum. This is that max force of static friction. So if I push with 3 Newtons and it doesn't move, friction must be pushing with 3 Newtons. So it ends up these things are equal. Okay, applied force and force of friction up to the certain point. Then it'll start moving. When it moves, I don't have to push as hard. Okay, no matter how hard I push, if it's moving, my applied force, and let's say that it's a constant velocity. Constant velocity. If it's moving at a constant velocity, then excuse me, I shouldn't have it this way. I should just say if it's moving, no matter how much I increase the applied force, friction will always be this value, kinetic friction. So the force of kinetic friction is always less than the force of static friction, but that max. Okay? So it's easier to move something, to keep it sliding, than it is to get it started. And so you're going to do a lab that looks very much like this. You're going to be pushing and pushing and pushing, and friction will push back, up until that instant that it starts moving. Then all of a sudden the friction will decrease, and you'll have this constant friction from then on. The last thing we need to talk about is how we calculate this. And it's related, the force of static friction is related to how hard the surfaces are pushed. So force of friction is related to how hard the surfaces are pushed together, which we call the normal force. If they're in tighter contact, meaning the normal force is greater, if they're in tighter contact, then the force of friction will be greater, both static and kinetic. So we have this thing called mu. It's a Greek letter. It looks like a U with a tail in the front. And that's called the coefficient of friction. And for this, the way we use it is there will be a mu static, and the force of static friction is going to be related to coefficient of friction times the normal force, and it ends up being less than or equal to that. In other words, really the max static friction force is equal to mu times the normal force. Let's say mu s is 0.4. Let's say the normal force is 100 newtons. By the way, the coefficient of friction has no dimension, because newtons times no dimension equals newtons. It's a scalar. So 0.4 times 40. The force of static friction is anything up to 40 newtons. If I push with 10, it can push back with 10. If I push with 20, it pushes back with 20. All the way up to 40 newtons. 40 newtons is that boundary condition. Okay? For the same object, let's assume the kinetic friction is 0.3. And if you remember what I said, is the force of kinetic friction is exactly equal to, it's constant, doesn't matter how hard I push, if it's moving, friction will push back with this same number. Whoop. So this would be 30 newtons. Okay, so the way we calculate the max static friction is mu static times the normal force. The kinetic friction all the time is mu kinetic times the normal force. And sometimes we just need to know more about the situation. Is it moving, to determine which of these we use? Going back to this is equal to mu static times the normal force, that maximum value. But notice, this force of friction, while it's not moving, could be any of those values. Force of kinetic friction out here is equal to mu kinetic times the normal force.